Let's try this one out. Problem number 3. Okay, so interestingly, it says P here and there's a theta, but we have to draw first a free body diagram. So free body let's go P diagram. All right, so we're gonna have this line here, this here. So this is going to be point there, and this is going to be F BD, and then it says for B theta equals 90 degrees. So we're going to also have a force P here. And of course, we're going to have AY and AX as reactionary forces. I guess FBD would be counteracting force P, so I'm going to draw instead going up. Now, what we could do is say that clearly the sum of the forces in the x direction are going to be AX plus nothing, so just AX equals 0. So we know that immediately AX just is going to be equal to 0. Now, if we take we can take the moments, right? Or no, we can do the sum of the forces, right? A FB. Well, it's going to have to be this angle here. We're going to have to remember this. This is 30 degrees. Well, actually, because that's 30 degrees, would we actually have sines and cosines for x? This angle, this force, is that going to be broken up into cosine 30, cosine 30? Well, let's find out. So, the sum of the forces in the y are going to be AY plus FBD sine of 30 plus P sine of 30. And we know that P is 4 plus 4 sine of 30. Okay. I almost want to say that this would be cosine. Cosine of 30. What's cosine of 30 degrees? That's not anything. What's sine of 30 degrees? That's half. So we actually could say 1/2 FBD. And this is going to be plus 2P. Because half of 4 is 2. Because sine of 30 is 1/2. Okay. Now with this, well, I guess this would have to be cosine. Because if this is sine, then the others have to be cosine. And also, FBD is going to be opposing P. It's actually going to be minus 2P. So AX plus... Well, it's really impossible to tell. I'm just going to say that AX equals 0. We don't know AY. We don't know FBD. We have one equation. Well, we can use the moments, right? Sum of the moments. Sum of the moments at, well, we have two unknowns here at A. So I'm going to do it at A. Sum of the moments about A. Some of the moments about A are going to be 12, which is our R, cross our F, which is going to be FBD sine 30. R cross F minus let's see, minus it's 18. Their distance cross our force, which is going to be, let's see, this would be counterclockwise. Clockwise is minus 18 times P, which we know is 4 sine of 30. So that means that this equals this. So 18 times 4 sine of 30 is 36. So now we know that 12 FBD sine of 30 is equal to 36. Now let's divide this by 12. 36 divided by 12 is 3. And then now let's divide this by sine of 30. FBD equals 6. So now that we know FBD equals 6, well, it says maximum magnitude of the average normal stress. Well, now that we know the force in this, let's write down what we know. Single bar is 1 inch wide, or we can say W equals 1 inch. Thickness, T, is equal to 1/2 inch. And the diameter of the pins, little d, is equal to 3/8 of an inch. Okay, so let's try this. So we know its width and its thickness, right? So the area is going to be these multiplied. So 1 times 1/2 is 1/2. So the force of FPD here times the area, which this is the area, is going to be 6 over 1/2. So keep it, change it, flip it. 2 over 1 equals 1. 6 times 2 equals 12. KSI. There you are.